5.16 output formation of integer value. Actually, hereafter we study how to format integer specifically, integer, floating point, character, string, all individually study. Actually, in the first chapter, we learned the simple output formations. These are general output formations irrespective of the data type, that is using escape sequences, that is simple output formation. Now, with every data type like integer, floating point, character, string, we learn specific output formations. This is like advanced output formations. You must be thorough with this. After learning this only, all outputs, because our outputs involve all types of may involve all the types of values like integer, floating point, character, strings, and all that. So by practicing all these programs, you can understand the output formation techniques, and then you can format outputs more elegantly. So try to understand this. And for writing an integer value, we write %d. Then there is an optional w, wd. W represents width. Width is an integer value. Width is a integer value always, and you can insert it. That means, suppose you have inserted 5. That means 5 positions, 5 characters are reserved for printing your output. And your output is printed always by default with the right justification. It is filled like this. Suppose the integer value is 123. How it is printed? Here 2 spaces are kept vacant. In this way, data to data, a series of data items you are writing, and whatever number of spaces you want to leave, that many spaces can leave. Simple thing. Suppose it is having three digits. Now you allocated 5 as the width. That means, what do you mean? 5 places should be reserved for my data, for my integer data, and my data item, my integer item, should be printed with the right justification. That is the meaning. I have given several examples for covering every case in this, and study it properly. Now you see page number 343. This is option case A. Here printf %d 12,345. So we haven't written any width, and 12,345 is just like that is printed. Next one, we have given %3d 12,345, but there is no impact. Here one thing you remember, when impact will be there, suppose if 5 digits are there, up to 5 digits there is no impact at all. Up to 5 digits system simply ignores. Then 6th digit, suppose width for this case, if you write 6, then it is meaningful. 6 means, what do you mean? Reserve 6 spaces for my data and print the number with the right justification. That is the meaning. And because you have written 3, then simply it is meaningless. Your 12,000 5-digit number never be condensed to 3 digits or 4 digits. That's why above 5 digits with reference to 12,345, if you write W above 5 only, it is meaningful. Otherwise, simply the printf statement ignores that. Now you see, you have written 3, simply it ignored that, and you have written 2 in C case, then also it simply ignored. So in this case, 12,345 up to 5 width specifier is ignored. And next case, B case, you see, B case, in B, D, you see, D. What do you mean by that? 8D, percentage 8D. Percentage 8D means what do you mean? Percentage 8D. 8 spaces are 1, 2, 3, 4, 5, 6, 7, 8. 8 spaces are to be allocated for printing your number. And the number is printed by default with right justification. Then how it is printed? 12,345. Here 3 spaces, leading spaces are left over. Now that is the meaning. E case you see 7D. 7D. What do you mean by that? 7 spaces are to be allocated for printing your number, and your number is printed with right justification. That always you remember, right justification by default. Next F case you see 6 spaces are to be allocated for printing your number, and it is printed with right justification. Now 6 spaces. What is the meaning of this? 6D. 6D. 6 spaces are to be allocated for your number, and the number is printed with the right justification. That is the meaning. That is the meaning. And suppose if you give 5, there is no impact. If you give 4, there is no impact. If you give D, how it is printed? Up to 5 it is printed like that. That means what you have to understand, if you write 1 with reference to this number I am talking about, with reference to this number, if you give width specifier as 1, 2, 3, 4, 5, there is no impact. From 6 onwards, impact you can see, observe this case. Next, now what I told you, the number is printed with right justification. Right justification can be converted into left justification by inserting the flag minus. The flag minus. Now you see, this is the thing, percentage minus 8D with reference to the printing of 12,345. What do you mean by that? 8 spaces are to be allocated for my number 1, 2, 3, 4, 5, 6, 7. 8 spaces are to be allocated for my number, and the number is to be printed with the left justification. Default is a right justification. By minus, minus is the flag. Already once I explained. Right justification is converted into left justification. Now number is printed 12,345. Here spaces will be left over. Next one you see, the case is minus 70 instead of minus 8, minus 70. Then what happens? Then this is the case. 7 spaces are allocated for your number, and your number 12,345 is printed with the left justification. That is the meaning. Next, you see minus 6D. Minus 6D. What do you mean by that? 6 spaces are to be allocated for your number, and your number is printed because of this minus flag with the left justification. So, right justification can be converted into left justification by inserting a minus flag. Now, next case you see, the J. In case of right justification, you know that leading spaces are created. See this example. Suppose with reference to the same number, then what do you mean by that? 8 spaces are to be allocated. 1, 2, 3, 4, 5, 6, 7, 8. And my number is printed with the right justification. That is the meaning of that. Then 1, 2, 3, 4, 5. Then leading spaces are created. If you want to fill these leading spaces with zeros, one technique is there. What is that? You write 0 here. then all these are printed with zeros. Suppose for the sake of security in financial accounting and all that, then this type of measure they follow, because somebody should not tamper this number. In order to prevent that, they print leading zeros. Leading zeros, that also automatically printed. For this, what should you do? You have to insert 0 here. Now you see JKL. J, what is the meaning of that? 8 spaces are to be allocated to print my number, and leading spaces are filled with zeros. That happened. Next, 0.07. 7 spaces are to be allocated. Leading 2 spaces should be filled with zeros. 0.6. 6 spaces are to be allocated, and leading space is filled with 0. Next, E case, you see the same principles, whatever principles we have discussed so far, all are applicable, equally applicable to long also. Now these are not only for int, these rules are equally applicable to long also. Now let us see the applications on the points what we discussed so far. 5.17, you see here the number is 1234, 4 digits. So now you see the printf statement. We have given width 2, it is just ignored. Width 3, that is also ignored. Width 4, that is also ignored. If width specifier, always you make out a rule. Width specifier is less than the number of digits, printf just simply ignores that. No error, it simply ignores that. Now you see 5 we have given. 5 means, what do you mean? 5 spaces are to be allocated for printing my number, and number 1234 is printed with the right justification. 6, the same. 6 spaces are allocated. Next, 7 spaces are allocated. 8 spaces are allocated. 9 spaces are allocated. In all cases, your number is printed with the right justification. I have given proper indexing. Only thing is, better than just seeing the program and you work out, you write this program and see the output, then you can realize that. Next, what point I explained, a right justification can be converted into left justification by inserting minus flag in the conversion specifier. Now you see 5.18. Now 8D, in the 9th line we have written 8D. 8D means it prints, obviously it prints 8 spaces are allocated, and your number is printed with right justification. And minus 8D. Minus 8D means that 1234 is printed with the left justification. 8 spaces are allocated. 8 spaces are allocated. 1, 2, 3, 4, 5, 6, 7, 8. And your number is printed with the left justification. That is the meaning. Next, 70. 70 means 7 spaces are allocated. Your number is printed with the right justification. Minus 70. Right justification is converted as left justification. Minus 6D. Minus 6D. For printing 1234, your 6 spaces are allocated. Your number is printed with left justification. Next thing, 15th line you see. 15th line, minus 8D. Sorry, 0.8D. 0.8D means 8 spaces are allocated for your number. 1, 2, 3, 4, 5, 6, 7, 8. And your number is printed with the right justification, and leading blanks are filled with zeros. That is the meaning of that. Next, 0.6. 6 spaces are allocated. Leading 2 spaces are filled with zeros. 0.5. 0.5. 5 spaces are allocated for your number. Leading space is filled with 0. That is the meaning. And here finally, regarding integers, I show you a special case. Practically in real-time environment it is required. Now you see, suppose you are writing this number 12,345, and for plus it is applied default that plus, if you write also, plus is not printed. Suppose next number, suppose minus 34,521, then it is printed. So next plus, if you want, you don't print, it does not print. Now you see, in this case, alignment, how we expect? We expect the numbers in a aligned order, suppose 34,251. So these are all positions wise, it is coincided. We can read it well, read all the numbers well. So by default, the type of arrangement is not there. If minus is there, minus is printed in first position, plus is not printed. So you can make plus is to be printed, otherwise blank space is to be printed. Ultimately, by inserting appropriate flags, you can align this type of cases also, that I want to show you in this program. Now you see, you want to insert, you want to prefix plus. Suppose if you give plus also, plus is not printed by default. But in order to make it coincided, you want to print plus, that you can do that. Now you see 5.19, you see percentage plus D 1, percentage plus D 12. Now you see plus percentage plus D 123. Now you force printf statement to print plus. So plus is to be inserted between percentage and D, then it is printed. Suppose sometimes these signs are printed, prefixing signs are printed. Some numbers you don't want to print signs. Then such case also, if you want to coincide, then you can find that you can force the printf to do that simply by doing this percentage space and D you give. Here leave space. Earlier what you did, here if you write plus, you are forcing, you are instructing printf to print plus. By default does not print. If you leave space here, it prints, it leaves a blank space. And minus, if you want to print, you get it printed just by putting minus to the number. Minus are printed automatically, minus by default is printed. So by following this technique, you can coincide numbers with the minus, plus, and without sign also. You can get them printed in a perfect order, and then the readability of the numbers will be improved.